How's everyone doing today? We are going to hopefully you all had a nice Thanksgiving break. Um, it was very, very, very nice to have a few days off because I mean I'm super excited for physics because who doesn't love physics? We're gonna get started today with our warm up for today. Um, so in this particular this particular scene, I guess. So you have a Lamborghini, you have a Lambo that's racing a farm truck in a drag race. What I want you to do, I want you to in the chat, I want you to put in which car do you think is going to be faster, and then how would you measure the speed of either car? So in the Zoom chat, I want you to answer which car you think is going to be faster, a Lambo versus a farm truck, and then how would you measure the speed of either car? Um, there's a lot of these videos on YouTube, and I think they're absolutely hilarious. But we'll take a couple of minutes for you people to take your guesses in terms of which car is going to be faster, a Lambo or a farm truck. Okay, we got Quinn for the truck. Anyone else? Anyone else have any opinions on which one's going to be the faster? We got a Lambo and we got a farm truck. The Lamborghini would probably win. Ooh, we got one for the Lamborghini, one for the. I don't know what kind of Lambo it is. Um, I usually don't go shopping for Lambos, so I'm not definitely not the car expert. We got Ethan for the farm truck. Um, so it was weird because fifth period was very pro Lambo, fourth period was very pro truck. So I'm very curious to see how sixth period feels about this about the farm truck and the Lambo. So the farm truck is about 28 bucks, and the Lambo is about 200 grand at least. So we'll see how you should spend your money here. Um, this is sort of a financial. I guess you can consider this a financial investment video, but we'll see. So we got three responses so far. Let's get a few more. It's not interesting. It's not interesting if we only have three opinions here. Okay, we got to get a few more. We got to get some controversial takes here. Little controversial, but maybe Lamborghini. Ooh, that is a little. It's weird that we would consider a Lamborghini beating a farm truck as being controversial, but I like that. We got a Lambo. We got two Lambos. We got two farms. Can we get a few more answers in here? Right? Can we get a few more responses? Right? It's more interesting when we have a lot of people. Okay, we got Alex for the farm trucks. Okay, we got three for the farm trucks, two for the Lambo. Let's get a few more here. Let's get a few more people. Let's get eight opinions here. Eight people who have their opinions on that. We got Armand. So I think we're tied. I think we're tied. I think we got four Lambos, four. No, we have three Lambos and four trucks. Three Lambos and four trucks. Okay. Okay. Can we hit 10? Can we get 10 people to put their money where their mouth is? Um, Farm truck and a Lambo. So I'll show you the video in a second in terms of who wins. Um, okay. The farm truck absolutely destroys the Lambo. There's a whole genre of these videos. I think Top Gear did a video on this where where these like you just see these like crazy like souped up like trucks just like absolutely wrecking a Lamborghini. Like so you have to realize that the Lambo is like a Lambo like they're fast. Like they can go 0 to 60 in like what 3 seconds or something. But that farm truck just like it wasn't even close. It absolutely got wrecked. So yeah, anyways, there's a whole genre of these videos on YouTube that are really funny. But yeah, so in other words, in terms of when you have a lot of money, buy a farm truck instead of buying a Lambo. Better financial investment. Okay, so let's talk a little bit about what we're doing today. So why are we talking about Lambos? It's because we're talking about the concept of speed and velocity. I'm talking about how fast things are. So naturally, I of course had to include the Lambo. And then there is a note sheet on Canvas that you can fill out. Here we go, note sheet that you should fill out and then submit whenever you're done. And then here is the link to the slides. Okay. So while you get that open, in terms of due dates, all assignments, you should submit them before the end of the semester. That's definitely a hard deadline here. Before, I'm sort of like, just submit it whenever you can. And now you definitely should submit it by the end of the semester because over winter break, I'm not going to be doing any grading. So submit it for the end of the semester. You have plenty of time to do so. Any revisions, anything like that, yeah. Please reach out to me if you have any questions about missing assignments or how you're doing grade-wise in the class. I haven't done a lot of grading in the last few days, but I will be grading this week quite a bit. So I should be able to give you some feedback soon. So yeah, that's about it. So we're gonna talk a little bit about what speed is. So I think for most of you, we have a good conception of what speed is. So in this particular video, the truck absolutely destroyed the Lambo because the truck definitely was faster. So when we say an object is faster, we usually say that it's right. It drives. It drove this. The truck drove the same amount of distance. Right, started from the start line to the ending cones. It started. It drove the same amount of distance in a lot less time, and that's why we. That's why we would say that's faster than a Lambo. So in other words, like we would say that speed just measures just how fast an object is moving, and we can measure the speed of an object by looking at how much distance it can cover in a certain amount of time. So if an object covers more distance over less time, it's faster. And if an object has less distance over time, right, it's going to be slower. So the main formula we're going to use to calculate distance is speed is distance over time. On this one, I definitely feel like we've all probably have seen something quite like this something before. And even if you haven't, I think you have a good conceptual understanding of this because we'll see in a second how you definitely have seen speed in your daily lives. But if you're just going to remember one thing from this, it's just that speed is just distance over time. So the speedometer in your car, so the speedometer of your car measures the speed of your car. It's called a speedometer because it's a meter that measures the speed of your car. So for example, if you're driving 60 miles an hour, it just means that in 1 hour you can drive 60 miles. It is something that you definitely have seen before. What we use in physics, so we use meters per second. So if you're running at 5 meters per second, which is a speed, it just means that in 1 second you can cover 5 meters, in 2 seconds you can cover 10 meters, and in 3 seconds you can cover 15 meters, et cetera, et cetera. So it just means that every second you can cover another 5 meters. Nothing crazy there, I think. And another thing is that speed can only be positive. So if you've ever backed up in your car or seen, the speedometer on your car, there's no like area for negative speed. There's no negative speed section, right? If you're backing up at 10 miles an hour, there's no speed, negative speed. And that's just because speed can't be negative. It just doesn't make sense to have a negative speed, right? Because negative speed is just how fast you're going. Whether or not you're going right or left, front, forwards, backwards, speed is just how fast you're going. We don't care about direction at all. We just care about how much distance you cover and how much time. So nothing crazy here yet. I think for the most part, I feel like we have a good understanding of speed just from our daily lives. And so we're going to do a little bit of a quick calculations for speed. So we got our my boy Khalid here. I'm definitely friends with him here. So Khalid, he's on a trip with his girlfriend, and he just wants to make sure they're starting off right. So they're on a trip. He just wants to talk and figure out where they're going before they get lost. Right. So they travel 200 meters in 40 seconds. Before Khalid apologizes for going too far, he did not mean to go 200 meters in 40 seconds. So what I want you to figure out is what is Khalid's average speed? On trip with his girlfriend. He wants to make sure they're showing off right. He wants to talk and figure out where they're going before they get lost. They travel 200 meters in 40 seconds before Khalid apologizes for going too far. What is Khalid's average speed? And if you're ready, just put your answers in the Zoom chat. You got Izzy here, fast off the starting line. We got Christina here, Dejora, Christina, got Lily. We got a few more answers here. All right, so if you're unsure of how to do this, just remember that speed is your distance over time. So I think we have a distance. Whoa, five exclamation marks. That's exciting. So we got Lily, we got Alex, we got Caroline, who's super excited because Caroline has five exclamation marks. We got Ava, we got Jody.
I
We
did
got
five exclamation marks because the answer was 5.
Yeah, I noticed. That was really clever. You get extra
Thanks.
credit for that. Yeah, extra credit. Yeah, you get an
Hey,
A. Yeah. That's how. That's how you get extra credit in the class, by the way. So great work, all of you. Loving the participation. So yeah, Khalid's average speed is 5 meters per second. If you're unsure of how to do it, it's basically we travel 200 meters. We have a distance of 200. We take 40 seconds. So we just take 200 meters and divide by 40 seconds, and then we get 5 meters per second. So nothing crazy yet. We'll do the crazy stuff in 1 second. So that's just speed. I think we have a good conceptual understanding of speed just from our daily lives. What is harder to understand is this idea of velocity. Velocity is the speed we have in a certain direction, right? If I say, hey, my cat is moving at 600 meters per second, I'm telling you my cat's speed, telling that my cat moves at 600 meters per second. When I say that the cat is falling downwards off of the Empire State Building at 600 meters per second, we're actually specifying the cat's velocity. And that's because we're saying the cat has a certain speed, which is 600 meters per second, and we say that as a direction because it's falling downwards off the Empire State Building. So there's a speed, 600 meters per second, and there's a direction downwards. Now, before you say that, Mr. You're a horrible person, just remember that cats have 9 lives. So if they die, they have 8 more lives. And also, cats are really good fallers. They legitimately don't get hurt from falling, unlike humans. So don't feel too bad. But even if they did something did happen, they have another 8 lives. So that's how cats work. So yeah, the key idea here is that velocity has a speed and a direction. You can't just have a speed. You have to have a direction as well. And that's velocity. So when we look at velocity, what we're actually looking at is basically how fast your position is increasing or how fast your position is decreasing. Another way of saying this is just that the velocity is our displacement divided by time. So what velocity is measuring is basically measuring how fast your position is changing in a certain amount of time. Right? That's what displacement is. Displacement is just a change in position. So if your position is changing, you're going to have some sort of velocity, and you can measure that based on how long it takes to change your position in a certain amount of time. Velocity is also sort of just like basically what direction you're going, right? Because if you think about position, there's a positive and negative position. If we have a number line, if we have an axis, we have a positive sign, and if we have a negative sign. So with the positive velocity, it means you're just moving in the positive direction. And then if you have a negative velocity, it just means you're moving in the negative direction. So if you're moving in the positive direction, your position, your displacement is increasing. And if you're moving in the negative direction, your position, your displacement is decreasing. So that's just velocity. Because of this, velocity can be positive or negative. Unlike speed, speed can only be positive, but velocity can be positive or negative. And again, velocity, when the velocity is positive, it just means that your position is increasing. And then when your velocity is negative, it just means your position is decreasing. So I think like definition-wise, I think velocity isn't too bad. What gets kind of nasty about velocity is when you have to start doing a lot of calculations with it, because displacement is a lot trickier to understand than distances. So we'll take a minute to look at how, we'll take a second before we move on and start looking at how we calculate velocity. So yeah, velocity is just your displacement divided by time. It's just how much your position is changing. Okay, so we're gonna do a little bit of a TBT, Throwback Tuesday. So this is back when I was in high school, a long time ago, easily several decades ago. So back when I was in high school, I needed someone to go to prom with. The problem was back in the day, we didn't do prom askings in person either. What I did is I went on Craigslist and I typed in nearest human willing to go to prom with me. And I found that the nearest human was 1,000 meters east on Craigslist. So I run 1,000 meters to the nearest person in 10 seconds. And then I reached the human. And then I realized that I actually got catfished and that the human wasn't real. I'm very sad about this. So then in order to take my anger out, I run 2,000 meters west. And I do that in 10 seconds. And then I go yell at kids to get off of my lawn. So very traumatic story. I just want you to feel really bad for me. You can say, Mr. Hu, your life is I feel so bad for you. I mean, you should, because my life was very difficult, as you can tell. So anyways, the question I have for you is, what is my average velocity during this journey? This is actually kind of a tricky question. I did not intend it to be this tricky, because there's a lot of different ideas here. But I do want to give you a chance to at least think about it, sink your teeth into it before I start looking at the different nuances. So let's try to figure out what my average velocity is during my journey. I've got a couple of people ready to go. Izzy and Quinn. Gabby, got Lily. If you want extra credit, you should include a lot of exclamation marks, and you should make sure you count every single one. So if it's 100, you should count out 100 exclamation marks, by the way. Okay, we got a few ideas so far. This problem is actually kind of tricky. And so while you keep working on it, I will start setting up for this particular problem here. That's a lot of exclamation marks, Quinn. I don't think that's enough, though. That's no extra credit for you, unfortunately. We got Alex here. We got Ethan. Ethan, that's not enough exclamation marks. That's definitely not. You actually count out 100? All right, I'm gonna count it out. 1, 2, 3, 4. That's definitely not 100. Actually, maybe it is. It actually might be. It actually might be. I actually wouldn't put it. Actually, I wouldn't put it past you. I feel like you definitely. If I said count out a million exclamation points to get extra credit, I guarantee you every single person would. So I wouldn't put it past you. There you go. I got extra credit. There you go. That's definitely how it works in this class. Okay. So I will take a look at this problem here. I'm going to shift our view here. And I show you why this problem is actually trickier than I initially intended to do so. So there are actually quite a few velocities here. What I intended you to figure out is your average velocity. But from my experience with fourth period and with fifth period, it's actually a little bit more. Whoa, that is a lot. Holy cow. Anyways, so it's actually quite a bit tricky because you have one velocity when you're going right, you have one velocity when you're going back left, and then you have one velocity like as an average. So this is actually kind of tricky. I intended for you to figure out your average, but I thought it would actually make more sense for us to look at the individual velocity calculations. So here's what I'm going to do. What I'm first going to do is I'm going to first take a look at what our velocity is when we are going right. That's how we can do this. So how do we figure out our velocity? So if you remember, our velocity is basically how much our position is changing over how much time. So To do this, we first need to take a look at what our position is. So we're going to assume that we're starting from 0. And then after 10 seconds, I moved 1,000 meters east. So what I'm going to say is that my ending position is actually positive 1,000 meters. Positive is very important because it signifies that we're going to the right. And so how do we figure our displacement? Our displacement is just basically how much did our position change. Well, if we started from 100, 0 and we ended at 1,000, our displacement here is 1,000. Positive 1,000, positive direction. Okay, so now let's figure out our velocity. Well, our velocity is our displacement over time. So if our displacement is 1,000 and our time is 10 seconds, velocity is 100 meters per second. Positive 100 meters per second. When we're going to the right. When we're going to the right. This is very important. This is the velocity we have when we are going to the right. We will see that we actually have a different velocity when we're going to the left. It's the same thing here. So where are we starting? Well, this time we're not starting from 0 anymore. We're actually starting from 1,000. So we're starting where this one ended. So we're starting from 1,000, and then we end, well, we go 2,000 to the left. So we start at positive 1,000, we go 2,000 to the left, we actually end at negative 1,000. So what is our displacement? Well, if we started at 1,000 and we ended at negative 1,000, our displacement is basically how much did my position change? Well, my position actually changed by negative 2,000. Position actually decreased by negative 2,000. So my displacement is actually negative 2,000. The negative is very important because it tells us the direction. So my velocity here would be negative 2,000 over my time, which is 10 seconds. My velocity is negative 200 meters per second. Again, so this one is my velocity going to the right, and this one is my velocity going to the left. So in other words, my velocity changed as I switched directions, which makes sense, right? Our velocity depends on our direction, so it would make sense that it would switch when we're going direction. Now, how do we figure out our average velocity? Well, it's actually quite similar to this. What we're going to do is we're going to start off with our starting position. Well, we started from 0. Not too bad. Let's take a look at our ending position. Well, this one's kind of trickier because we are not ending here. We are actually ending all the way over here. So our ending position is actually negative 1,000 meters. So what does this mean? It means that our displacement from our beginning to the end is negative 1,000. We actually don't care that we went right. We only care about where we started off and where we ended. Okay, so what would our velocity be? Well, our velocity would be our displacement over time. Our displacement is negative 1,000. Our time is 1,000. So our velocity would be negative 50 meters per second. So this is our average velocity for the whole journey. Not quite the for any particular section. And this is why it gets kind of tricky, because we only care about where we started and where we ended. We don't actually care about this other middle jump or average velocity. However, if we were to figure out our average speed, then we would care about all this junk in the middle, the junk in the front. So let's take a look at the average speed. Our speed, if we remember, is our distance divided by our time. So how far did we go in total? We actually went 3,000 meters in total. So if we take 3,000, which is our distance, and divide it by 20 seconds, we get that our speed is 150 meters per second. This is our average speed for the whole time. So this right here, all right, right now this is kind of tricky. We got a velocity going right, velocity going left. We got an average velocity, we got speed. And this is why it gets kind of tricky. I'm going to try to be careful with my wording here when I'm writing problems. If I mean average velocity, I mean for the whole thing. I mean average speed, I mean the whole thing. And then if I say my velocity from like any particular direction, what I mean is the velocity for this section. So it's going to be important to differentiate between these things. And average velocity and average speed are going to be the hardest ones to differentiate between. Because average velocity, we only care about our starting, and we care about ending. Average speed, we care about the whole thing. And that's kind of tricky to understand. So again, this is just sort of talking about the same problem here. So at initial time, when time is 0, we're starting at our initial position, which is 0. At 10 seconds, our initial position is 1,000. At 20 seconds, our position is negative 1,000. So what this means is that our total displacement from the beginning to the end is negative 1,000. Our total time is 20 seconds. So if we figure out our average velocity, it's negative 1,000 divided by 20, which is negative 15 meters per second. Our total distance is 3,000 meters, and this is actually kind of tricky because we went 1,000 to the right and we went 2,000 to the left. So our total distance traveled is 3,000. Our total time is 20 seconds, and so our average speed is 3,000 meters divided by 20 seconds, which is 150 meters per second. So that's why this can get kind of confusing pretty quickly, but we'll have plenty of practice. And I want you to notice just how velocity can be positive and negative. And that velocities need to have a direction. I want you to try to indicate whether or not it's positive or negative, because if you just say 50 meters per second, I don't know if you're talking about speed or you're talking about velocity. So they should have a direction. And notice how speed can only ever be positive. Okay, so in your own words, so there should be a space on the note sheet for this. I want you, in your own words, I want you to write down the difference between speed and velocity. So try to explain it in a way that makes sense to you. If you're a little unsure of what the difference is, you can always ask me, and I can always try to explain it. But see if you can try to write it down in a way that makes sense to you. And then afterwards, I want you to answer this question here. So this question talks a little bit about Owen Wilson and Keanu Reeves. Owen Wilson and Keanu Reeves were starring in a movie called Bill and Ted's Excellent Adventure. Easily one of the best movies made of all time. Won several Academy Awards for their excellent performances as Bill and Ted. And so I don't remember who plays who. I don't know if Owen Wilson was Bill or Keanu Reeves was Bill. But anyways, for this problem here, we have two cars here: Owen Wilson's car and Keanu Reeves' car. Owen Wilson's car is traveling 400 meters per second northwards. Keanu Reeves' car is traveling 400 meters per second southwards. So I just want you to answer: do both cars have the same velocity, and do both cars have the same speed, or maybe both? So we'll take a few minutes to go through this. And if you have any questions or if there's anything that I missed that you want me to go over, just let me know. I can go over it again. Ooh, that's a good answer, Alex. What Alex is saying is that speed is the rate at which an object covers distance. Velocity is the rate at which the position changes. Alex, I really like your definition. So again, you can use your own words for this. I want you to write it in a way that makes sense to you. You don't have to share it with the class. Write it down in a way that makes sense to you. I really like Alex's definition. If you want to use Alex's definition of the two, that's also good. But I want everyone to sort of have a way to remember it in a way that makes sense to you. And then whenever you're done with your definition, see if you can figure out which car if Keanu Reeves' car and Owen Wilson's car have the same speed, have the same velocity. Owen Wilson would technically be Lightning McQueen because Owen Wilson plays Lightning McQueen in Cars. And Keanu Reeves, his car. I don't know whose car he would be. Yeah, so do both cars have the same velocity? Do both cars have the same speed? Does anyone have any answer for number two? Does anyone have any ideas of which car? Do both cars have the same speed? Both cars have the same velocity? Any ideas? They're both going 400 meters per second. One's going north and one's going south. What does that tell us about their speed or their velocity? Well, because Owen Wilson and Keanu Reeves' car are both going at 400 meters per second, they both have the same speed. Both have the same speed, having the same speed. However, they don't have the same velocity because one of them is going like this, and then the other one's going like this. So you have two different directions here, and so they don't have the same velocity. Because one of them points north and the other one's going south. So in a sense, one of them is actually going to have a positive velocity, and the other one's going to have a negative velocity. All right, so we're going to take a look at another problem here. Okay, so here's what's happening. So one day I decide that I'm done being 5'11". I want to be over 6 feet tall. So I decide that I'm going to go 6 and 7 inches taller, and then I gain 60 pounds of muscle. So now I am just absolutely shredded and absolutely yoked. And so because of now, I'm super physically gifted now. I decided I don't want to teach anyone. I'm going to play in the NBA because NBA players make a lot more money than teachers. So I get signed by the Boston Celtics. And then so Paul Pierce into the 2008 NBA Finals against the Lakers, he has a quote unquote knee injury, and so because of this, I play 30 seconds in game one, and then Paul Pierce miraculously comes back to ice the game. So the legend has it that Paul Pierce faked an injury so he could go to the bathroom. The legend is that he may or may not have had an accident in his pants, which is very unfortunate. I don't, I'm not sure if that accident happened or not, but I think it is very interesting. But the important part is that I played 30 seconds in game one of the NBA Finals because during my 30 seconds of game playing time, I ran 4 meters east, I ran 2 meters south, I ran 4 meters west, and then I ran 2 meters north. So starting in the top left corner, I ran 4 meters east, 2 meters south, 4 meters west, 2 meters north. So I want us to figure out the total distance I traveled, the total displacement I have, average speed, and then the average velocity. So I'm actually going to put you all into breakout rooms just so you have the chance to, you can work together. and you can chat a little bit and see how everyone's doing. And then I'll bring you back in a few minutes once everyone is sort of ready to, once sort of everyone has figured this out. So I'm just going to open them now, and then we'll come back in a few minutes. So go say hi to people, see how everyone's doing, and then we'll come back when everyone's ready with an answer, some answers for some questions here. Okay, so I will just quickly go over what we do. Okay, so what is my total distance I traveled? So hopefully you're all able to work together and get some ideas together. So I'm just gonna quickly go over this. So what was the total distance I traveled? Well, I traveled 4 meters, 2 meters, 4 meters, and 2 meters. So 4 plus 2 plus 2 is 12. So I traveled 12 meters total. What is my total displacement? This one's kind of tricky, but I started in the top left corner, and then I go wee, woo, wee, woo, and then I end in the exact same position. So my total displacement is actually 0. Very tricky, but if I start and end in the exact same position, my displacement is 0. Okay? So now let's figure out our average speed. Well, our average speed is our total distance, which is 12, divided by our total time, which is 30. So 12 divided by 30 is 0.4. And what is my average velocity? I could do some very nasty math for it, but if our displacement is 0, that means our average velocity is 0. And our velocity is our displacement divided by time. So our displacement is 0 because we started and ended in the exact same position, and then our time is 30. So 0 divided by 30 is just 0. So if you check our answers here, we'll get that. Yep, that it is indeed 0, and our average speed is indeed 0.4 meters per second. My total displacement is indeed 0, and my total distance is indeed 12. So hopefully you were able to get something similar to this. I think the trickiest part is the displacement part, and then maybe the velocity part. But I think overall, I think it's, once we sort of a visual idea, I think it's okay. Okay. So now I'm going to just quickly go over this idea of constant speed and velocity. Now, this isn't really something you're ever going to have to calculate, but it is something to understand what it means. So when I have a constant speed, it just means my speed is not changing. It's just I'm not speeding up, nor am I slowing down. So it's if I'm driving, it's like what happens when you stick your car in cruise control, right? Where your car is in cruise control, it's literally just making sure that your car stays at the exact same speed the entire time, no matter if you're going up or if you're going down. And that's what constant speed is. Your car is in cruise control, and then its speed is constant. Constant velocity means you both have a constant speed and you have a constant direction. So, and what constant direction means is that you're in a straight line. So constant velocity means you have to drive in a straight line at a constant speed. So what it means is you're in cruise control and you're never touching your steering wheel. Because if you touch your steering wheel, you're turning your car, which means that your car is no longer in a straight line, which means that you're not at a constant velocity. So basically you're driving, in a sense, kind of blindfolded with a pure car on cruise control. Not ideal, don't do that, but that's what constant velocity is. You have to have a constant direction and constant speed. So if I just get my driver's license and then I decide I'm going to celebrate by doing donuts in a parking lot. So that's what everyone does, right? When you get a driver's license, you do something stupid like doing donuts in your car, driving in circles at a constant speed. We want to know is my car also driving at a constant velocity? Well, here's the thing. This one's actually kind of tricky because a lot of people, the idea is sort of, okay, I'm driving in clockwise or whatever, so I'm going the same direction the whole time. But the thing is, because you have to touch your steering wheel in order to turn, you're actually not going at a constant velocity. Because 1 minute, technically you're going to the right, and the next minute when you're down here, you're going to the left. So your direction is just constantly changing throughout the whole time. So when you're in a circle, you are not driving at a constant velocity, even if you're driving at a constant speed. Kind of tricky. Okay, so that's just for constant speed and velocity. It's not really computational heavy, but it is important just because in this unit, our speed and velocity is not going to change within any particular section, right? So if we look at our previous problem when I was attempting to get my prom date off of Craigslist, right? So when I was going right, my velocity is constant. My velocity is, when I'm going left, my velocity is constant. They might switch between sections, but within that section, it stays the same, and that's important. And that's really what the gist of constant velocity and speed mean. Well, what I talk about now is something like graphing it visually, because a big part of distance and displacement and velocity and speed is you can graph it with respect to time. So you can show how you're moving and where you're going with respect to time. So right now I don't have a graph for this because the next slide will have a graph. I'm just sort of going over a couple of important things right now. So in a distance versus time graph, the slope is your speed, right? Because the slope measures how much something changes, your y changes, if your x changes. So in a distance versus time graph, you have your distance on the y-axis and the x time on the x-axis. So your slope just basically means if I'm traveling some amount of time, how far does my distance change? And that rate of change is just called speed, right? So very important. If you have a distance versus time graph and I say, hey, what is my speed? You just need to figure out the slope at that point, at that particular point. Similar for displacement versus time. So a displacement versus time graph, this is one that tracks your position with respect to time. And so the slope of that is your velocity at that point. So a displacement versus time graph, you can have your axes like this. You can have a y-axis, which is your displacement, your x-axis, which is your time, and then so you're gonna have something like this. And the thing is, your displacement can't be negative, right? Because you could be down here, because you could be to the left of your starting point. Whereas your distance versus time graph is always gonna be positive. And the slope of your displacement versus time graph is your velocity. So if I say, hey, I need to figure out what's the velocity at this particular point in time, you just need to figure out the slope at that point. And a continuation off of that is that the speed of a displacement versus time graph is the absolute value of your velocity. So what is an absolute value? An absolute value is just make sure that it's always positive. So if you have a negative velocity in your displacement versus time graph, the speed of that is just the positive of that. So just make sure it's always positive. And then very quick, a steeper slope just means you have a faster speed. Okay, so now let's take a look at what this means. So first off, this is a displacement versus time graph. We have displacement on the y-axis and time on x-axis. But I'm going to just read the story real quick. So basically, I don't know if I ever told you, but my life is very difficult, very challenging. So back in my day, so I'm from the Bay Area, if you don't know. And so in the Bay Area, it snows a lot, especially around here, it snows a lot. So every morning back in the day when I would go to school, I walk barefoot through the snow, uphill, both ways, on a straight road from home to school, because you kids have it easy with your non-snowy downhill both ways. I had to go uphill both ways when I was going to school. And so this graph shows my particular journey one day. So in here, I have my displacement on my y-axis, and I have a time on an x-axis. And what this is showing is basically, displacement is basically just showing where I am relative to my initial position, right? So if I'm here, that means that I'm 20 meters away from my initial position. Here means I'm 40 away. All right, so this is tracking how far am I away from my initial position, starting position. And this time just tells me how much time has elapsed when this has occurred. So what I want you to do is I want you to figure out 4 things. I want you to figure out my displacement at the very end of my journey. What is my total displacement? In other words, how far am I from home? When am I walking towards my home? This one's kind of tricky. When am I walking the fastest? And then when am I standing still? So what is my displacement at the end? When am I walking backwards? When am I moving the fastest? And then when am I standing still? I'm gonna open the breakout rooms again to let you work in your group, and then I'll see how everyone's doing. And then afterwards, I'll show you what I mean with these questions.
Mr. Who?
Hi.
Hi, I'm having like
Yeah,
issues.
yeah.
My computer just broke, but it's not letting me. Oh wait, yeah, it is. Sorry, never
Yeah.
mind. I was gonna say, okay, never mind.
Okay, so I'm gonna start going through this just because I know this can be kind of tricky. I don't want anyone to feel like this is, ooh, where'd it go? Hold on. So basically for the first question, when it asks, there we go, okay. So for the first question, I want to ask what my displacement is at the very end. That's basically just asking, what is my position at the very end? So if I look at the very end here, my position is 160. So my displacement is just 160. That just means how far I went at the very end. When am I walking towards my home? This is basically just asking when am I going backwards? So when I'm going backwards, this means that my position is decreasing. In other words, I have a negative velocity, my slope is negative. So there's only one section in this graph where my slope is negative, where I'm walking backwards, my position is decreasing, and that's between 50 and 70. So if you see here, my position is increasing, I'm going forwards the whole time, and then at 50 seconds, I start going backwards. And then and at 70 seconds, I start going forwards again. So this section right here between 50 and 70, that's when I'm moving backwards. When am I moving the fastest? This one's kind of tricky. So when I'm moving the fastest, what I'm asking for is basically what is my speed the greatest? In order to do this, I need to look at the slopes, but I also just basically need to look at just the numerical value of the slope. I don't really care about the speed. So to figure out the slope, what I'm gonna do is I'm gonna do a rise over run here. So the first section here, I go up 100 over 50 seconds. So my slope is 2. Here I go down 60 in 20 seconds. So my slope is -3. So my speed would be 3. And then here I go from 40 to 160. My slope here would be 120 divided by 30. So it would be 4. So this part right here has the steepest slope. So between 70 seconds and 100 seconds, I have the steepest slope. So that would be when I'm moving the fastest. And then last but not least, when am I standing still? Well, when I'm standing still when my position is just not changing. And that's only one particular point in time. And that's between 100 and 120 seconds. So I know that was a little bit rushed. Hopefully you were able to understand part of that. We'll get more practice with this for the next few days. But I just want to go over the one last thing we have here. So again, reiterate, my displacement at the very end is 160. I'm walking backwards between 50 and 70 seconds. I'm moving the fastest between 70 to 100 seconds. And then I'm standing still between 120 seconds. So the next thing I'm going to do here is I'm actually going to draw a velocity versus time graph just because I think it would just be easier for me to just show you what I mean by that instead of just asking you to do it. Also for timing's sake, just because it would be hard to just figure out by yourself. So basically in this graph here, there are 4 sections. Within each section, they have constant velocity, right? So what I have here is I have a velocity versus time graph, where velocity is on the y-axis and then time is on the x-axis. So there are 4 sections here. There's section 1 where you're going up, your position is increasing. Section 2 when your position is decreasing. Section 3 is where your position is increasing again, and then section 4 when your position is not changing. So each one of these sections has a different velocity, but within that section, your velocity is the same. So in order to draw a velocity versus time graph, we basically need to figure out what are the velocities for the 4 sections. So there are 4 sections here. Section 4, because it's not moving, it's just 0. Section 1, to find the slope in section 1, I can just do rise over run here. Rise, I go up 100, I think, and then my run is 50. So my displacement increased by 100, while my time increased by 50. So 100 over 50 is 2. So my slope for this section is 2. For here, it's similar. I drop -60 over 20 seconds. So my slope is -3. And then here I went up, it was like 100 over 120, I think, over 30 seconds. So it would be 4. Okay. So sorry, I quickly just went through the slopes. I feel confident that you know how to calculate slopes because the harder part is actually being able to draw this out. So the first thing you want to do is it helps to label your time graph to show each particular section. So the first section occurs between 0 and 50 seconds. So could you show? Oh, did I not? No. That's no. There we go. There we go. Sorry, I gotta switch it. Yes. So again, so what I did here, I just calculated the four different slopes here: -2, -3, 4, and 0. That's just for each one of the sections where the slope changes. It helps to label your x-axis here with the different points in time where your slope changes. So the first section is between 0 and 50 seconds. The next section is between 50 and 70. The next section is between 70 and 100. And then between 100 and 120, that's our last section. So within each section, it has its own particular slope, its own particular velocity. And so what we're going to do is we're going to try to graph it out. So the thing that's very important is our velocity is constant within each section. When you have a constant velocity, it means that your velocity is not changing. It's just a flat line. So for the first 50 seconds, my velocity is 2. So what I'm going to do here is I'm going to go 1, 2. So at 2, my velocity is 2 for the whole of 50 seconds. So it's just one horizontal line for 50 seconds. So my velocity is always 2. For the next 20 seconds, my slope is actually -3. So what I'm going to do is I'm going to go down 1, 2, 3. And then between 50 and 70 seconds, I'm going to draw another horizontal line where -3 is. These lines are not connected, and that's because it's for a reason. It's because their velocity is just sort of jumping between the two. We're not really including like a smooth acceleration. So you can just draw a dotted line to really make it easier for yourself so you can visualize what's going on. But basically your velocity is just jumping from 2 to -3. You're saying your velocity is -3 for 20 seconds, and then it jumps up to 4. So go 3, 4, up to 4, another 30 seconds. So you go from 2 to -3 to 4. Another dotted line here. And at the very end, when you're at a standstill, your velocity is 0. So very important, when you're at a standstill, when you're not moving, your velocity is 0. So for this section, I draw a blue line where your velocity is 0. So that's what a velocity versus time graph would look like. There's a lot of different sections with a lot of different horizontal lines. And so we're going to be looking at some more of these in the next few days. But I just quickly drew one here just so you have an idea what this looks like. And the key idea here is that you have a lot of horizontal lines. Within each section, you have the same velocity, and then your velocity will jump between sections. So we will do some more of this later on. Yeah. Sorry, we had a lot of material to cram today. So because of that, I know it was a little bit more rushed than usual. But hopefully you were all able to feel like you have a gist of it. We'll be looking at this more for the next few days for finals week. And then for the rest of this week here, I'm going to wrap up since we're out of time. You don't have any homework. You don't have an asynchronous assignment. If you have any work you need to turn in, any revisions or anything late, you can keep submitting those, but submit it before the end of the semester. I haven't really graded anything recently, but I will be grading throughout this week, so keep working on those. And we will pick up where we left off on Friday. Other than that, I will see you on Friday, and I have office hours again from 2:40 to 3:40 today. So other than that, I will see you on Friday. Have a good one. Hope you had fun. Hope your Thanksgiving was good. I'll see you later. Bye-bye.
Thank you.
Bye.
Thank you.
Bye.
Thank you.
Bye-bye.
Mr. Hu, I was wondering when the last day would actually be like of the end of the semester.
What, last day?
Like,
would be
Do you mean
would
it would be
consider-
due like this Friday, or it would be due like
Yeah.
at the actual end of the
the
semester?
Friday of finals week is what I would consider to be. the
Oh,
end of it.
okay. Because some of my teachers were saying like the end of the semester for them is technically like this Friday.
This Friday?
I think it's
Did
just
you-
because like they consider like finals focus week like a different thing or something like that. I don't know.
Oh yeah. So I mean, the thing is, okay. So we're not going to have